Typical scenario for potential function case is how number changes not depends on percentage, but depends on amount of units. For example, if we need to calculate decreasing cost depends on how many units we can produce, we can use a potential function. For example, if we want to know how much our production cost decreases depends on amount of units that we are producing, and we know that correlation is not linear, meaning that we cannot just multiply amount of produced units by cost of each unit. In that case, we can use a potential function. For example, we want to produce 500 units and cost of each unit will be $100. So we cannot just multiply 500 by 100 and get a production cost, because in that case it will be linear correlation. We can use a potential function instead. So 500, and this is a constant, times 100 in the power of, for example, 0.8. 0.8 is a diminishing factor and it's a constant, and our production cost will be more than $7,000. Again, typical scenario for exponential function usage is when we increasing our number by percentage each period. Typical scenario for exponential function is when we change in number depends on units and not a percentage.